The next presenter is, again, Matt Griffin, the Director of Community for Ultimaker North America, who's going to give us a quick materials overview. And again, this will be covered in more depth in a longer session.
Great. Okay.
Table.
See slides? Okay, I'm going to do a 5-minute wait. Set an alarm. I will not miss the end of... Okay, I'll set it for 4 minutes. Okay, so 3D printing materials. It's a big topic. I can't get through everything, but I wanted to mention, we offer the Ultimaker S5 Pro Bundle, which includes the material station, because we are just really focused on making our tools a really great platform for leveraging a huge range of materials and solving things like, for example, with the material station, the fact that it keeps your material stabilized, humidity-wise, really opens up some of these exciting composite materials and some of the, the popular, Ultimaker materials to longer use. So I wanted to mention that. So we have a baseline that's already a bunch of engineering properties that you can get, but it's an open system. You don't have to use our stuff, and there is just a huge wealth of things. But to point out some of the range, PLA is by far the most popular, and one of the reasons that it's popular is it's just so easy to process. And it shrinks pretty much the least of most of these materials. So you can really print something and be pretty confident it's going to be pretty spot on to your design. And it welds down to itself, really easy to process. But you may have properties you want to achieve, functional prototypes, et cetera, that need more wear resistance, need to be flexible, need to be chemically resistant. And you can see a bunch of options here. But I want to jump right to this. So you can use support materials, secondary materials that you're not using to necessarily build your part, you're using it to enable the building of a part in a two-material machine. PVA has been around for a long time. We think that the formulation we picked is pretty good. There's a bunch of formulations, and they range in how flexible, and you'll see different colors. But in general, what it allows you to do is print without being as fussy in your design for designing for the technology. So you can support an overhang that is not, it's too steep without having to go in with clippers and really clean up if you make print support in the same material as you're building. PVA is nice because you don't need a workshop and lye, to strip out that material. You can put it in water. And one consideration to think about with this is that if you can agitate the water, if you can, basically get more water moving past those parts, it's really handy. But also, one of the main things that we encourage a lot of our customers to do using Cura is to actually go in, only set your interface, support interface to the support material, leave everything else with the primary build. So you just get this nice interface right up against the part, much faster to remove. Breakaway, completely different solution. You print right up against it, but it doesn't chemically bond. So it's really nice. You can peel it away when you're done at the end. And there's a bunch of materials that are better suited to that. I have a slide later, but I'll just go on and mention it now. There are now some higher temperature water-soluble materials that are compatible with a bigger range of materials, including a lot of the nylon composites that are at the top of our temperature range. This is really handy. This means you can do really complex parts in these abrasive materials. So so watch for that. Aquasys from Infinite is one of the options out there. So there are a huge range of engineering properties you can achieve. This is a chart. We're going to share these presentations, so you can look at this on your own time to see how do these various materials break down as far as stiffness versus ductility, toughness, hardness. Take a look at the way that each of these materials, the base polymer, but also the way with the various compatibility additives in them, way they behave is unique. It's really critical when you're evaluating 3D printing materials to read the technical data sheets and see what is in there and what the processing instructions are, including compatibility. But I want to, end on this. So we have reached out and we've been partnering with a lot of the top chemical companies out there to help them produce profiles. So you can very easily use materials, third-party materials on our platform. So we have the Material Alliance, and I think over 200 materials right now. There's even a bunch of materials that are going to be coming into the system soon. And you can go to ultimaker.com to the materials section and now look them up by material property. I've run out of time. This is just a little sneak preview that we actually, how we work with the chemical companies to help them play a leading role, because they really understand these polymers better than we do. They can use software tools and baseline parts to get to those profiles. And so then all of you can get a huge range of material properties out of these. We'll have more time to talk about this in the future and exciting things like this, sharing all the kinds of materials flowing through and the properties, but I will stop there.
Thanks a lot, Matt. That is definitely a topic that we would have plenty of more to talk about. So I hope the rest of the folks here will join us. That Materials Roundtable is this Wednesday at 11 a.m. Central Time. And again, we sent an email this morning, but we will send another email with all these links so you can get these sessions on your calendar.